So this is the video for the chapter 10 video assignment, and we're given 3 parts to this question. First part being the how much iron is formed in the reaction in mass, or how much the mass is. B is what is the formula for the unknown oxide that we're not given, and then C has to do with the unit cell, and I'll get to that one later. But I want to start with, they gave us in the question, we're given the pressure, volume, and temperature of the CO2 that will be produced. And so I use that, and I use the PV equals nRT to find out how many moles will be in that reaction. So we kind of start there. And from there, I'm going to go kind of to the second part to figure out what the correct equation, or what the correct oxide is, so that we can figure out how much iron is being formed. So we'll go to that. And what I did is that, because we're given 2.66 grams of whatever oxide this is reacting, I found for each of the potential oxides, which are here are the equations, I found the moles for each one right here. And so in order to find which equation is correct, I plugged each of the numbers in, and the correct equation should have a matching ratio for moles and the equation. So for example, if 0.017 moles of this iron oxide should produce 3 times as many moles of the CO2, and then so on with each of the equations. And so I did that, and as you can see, I lightly circled this middle one. So 0.011 moles of this oxide will produce 4 times as much CO2, or 4 times as many moles of CO2, which is this number right here. So this is the number, this is the equation I went with, and this is the oxide that it is. And so from there, we know that 2.66 grams of that oxide is reacting. So kind of using this number, I plugged it in, and this is a little simplified form of that equation. So 0.011 moles of iron oxide, of this form of iron oxide, should react to make, and if we look to this equation, 3, so it should be 3 times as many moles. So I did 0.033 moles of iron. And so doing the math, converting it to grams, it gives us 1.84 grams of iron forming. So there's that. And then kind of going to question 2, we already went over a little bit. Using that method, that I was able to find out that it was the Fe3O4, or this equation was correct. And so that one's kind of, we already did, because it was necessary to find the first part. So we'll go to the third part, and we're given that this one side of the unit cell is 839 picometers, so I converted that to centimeters, and then by cubing that number right here, it gives us 5.91 times 10 to the negative 22nd centimeters cubed, and that's the area, or the volume, sorry, of the unit cell. And so we have that volume. Now we need to find the volume in milliliters of the iron oxide. So we were given the density, so we can use the density equals mass over volume equation to give us 0.51 liters, because this equation's in liters. So 0.51 liters of this iron oxide, so we can convert the liters to milliliters, and that gives us 510 milliliters. And so from there, so now we have the volume of both the unit cell and the oxide. We can then do the math, this divided by this, in order to find out how much there is of this in the unit cell. So I did the math, and it came out to 1.16 times 10 to the negative 24 units, or atoms, I guess, in this unit cell.